Hi everyone, I am Messias Filho, and I'm going to present the work called Self-adaptive Microservice-based Systems, Landscape and Research Opportunities, which has been made in conjunction with other colleagues from the State University of Ceará. So, in this presentation, I will follow these topics, starting with a brief introduction, then I will present the systematic mapping developed and the main results. After that, some research directions I presented, and finally, I conclude the presentation. So, the microservice architectural style arises as a strategy to develop a single application as a set of independent small services. Among the main benefits of microservices, we can cite the technology heterogeneity, resilience, ease of deployment, and for this reason, the microservice-based architecture has been used as an alternative to the traditional monolithic architecture. The popularity of this architectural style has grown, boosted by its adoption by several large companies such as Netflix, Amazon, LinkedIn, among others. It has also attracted the interest of the academic community and other areas of research such as blockchain, IoT, and mobile systems. But despite its benefits, as the number of deployed microservices increases, so does its complexity, bringing some challenge to this architectural style. Because of this, new methods and tools needed to be introduced to reduce complexity and keep it at manageable levels. One approach that has been used to solve or mitigate those problems is the use of self-adaptation, which allows the system to adjust its behavior or structure at runtime in response to environmental changes. This paper aims at investigating and exploring the use of self-adaptation techniques and mechanisms in the microservice architectural style in order to understand how those concepts have been used to improve microservice-based systems. To do that, we conducted a systematic literature mapping that contemplates 10 primary research questions answered by 21 studies taken from 5 digital libraries. Our main contribution consists of the analysis and discussion of the state-of-the-art of the studied subject, thus helping researchers and practitioners to understand how microservices are currently benefited by the use of self-adaptive techniques, such that they can possibly reuse and extend such approaches in their own work, and to address current limitations of those studies by new research directions. In the next slides, I will present our systematic mapping study that followed the guidelines well established in the literature. That study consists of 3 phases. The first phase is planning the mapping, the second phase is conducting the mapping, and the final phase is reporting the mapping results, which will be explained in more details in the following slides. Talking about planning the mapping, in this phase, we planned the details about the systematic study mapping through a mapping protocol. Based on our main goal, 10 primary research questions were formulated to guide the research methodology, in which we could explore more details about the selected studies. We performed automatic search in 5 electronic databases, and a snowballing process was used in the selected studies. And finally, the research was conducted between February 20 and May 20. In conducting the mapping, at this stage, the mapping protocol defined in the planning phase was executed. In the first phase, an automated search was performed by executing the search string in the electronic database defined in the protocol. At the end of this phase, a set of 8 and 15 articles was returned. In the second phase, manual filtering was performed on the base for which it wasn't possible to search studies considering title, abstract, and keywords automatically. At the end of filtering, a total of 150 works were considered studies suitable for the next phase. In the third phase, for each selected study, it was read the title, abstract, and keywords to filter the studies based on the selection criteria. At the end of this phase, 37 papers were evaluated as potentially relevant. In the fourth phase, the filtered studies were entirely read. This process resulted in 19 papers considered relevant. Finally, we applied the forward and backward snowballing technique Considering the selected papers, at the end of this phase, you obtain 2 more new papers, resulting in a total of 21 relevant studies belonging to our final set. Now I'm going to show the mapping results. Due to the time, we only show the results of some selected research questions. Despite this, all questions are formally answered and their results can be found in the main publication. The first research question is a qualitative research question, in which we present a brief description of each selected study and how they used self-adaptation in their proposals for microservice systems. Due to the time, it will not be possible to detail each study in this presentation. However, the results show that most studies have used the MAPK control loop in their solutions. In addition, most of the proposals are self-adaptive reference architecture models and frameworks that use self-adaptation to ensure more resilient and scalable microservices autonomously. The research question 3 aims at identifying where the contribution of each study is, taking into account the phase of the self-adaptation control loop. The results show that 9 studies didn't focus on a specific phase, which means that either the solution traverses all phases or the contribution of the work is not within the feedback control loop. Next, 6 studies focused on the monitoring phase. There was only 1 study that focused on the combination of the monitor and the analysis phases. 1 study whose contribution touched the monitoring, analysis, and planning phases, and 1 study that addressed the analysis and planning stage. And finally, 3 studies didn't apply any type of control loop. These studies are philosophical papers that didn't use any phase and didn't give further details on the topic. In the fourth research question, talking about what self-properties have been addressed, the results show that only 3 self-properties have been explicitly addressed by the studies. The first one, self-healing, is addressed by 5 studies. This property is used for anomaly detection, resilient scalability, reallocation of microservices, and so on. Next, self-management is addressed by 3 studies, and finally, 2 studies address the property of self-optimizing. On the other hand, 14 studies didn't specify which self-property was the focus of the adaptation proposed. The research question 5 aims at to discover what self-adaptation strategies have been used. The results show that the vast majority of studies used reactive adaptation. On the other hand, only 1 study proposed a proactive adaptive solution and another one used a hybrid solution. Finally, for 2 studies, it wasn't possible to identify which strategy was used. The next question is related to the quality requirements addressed by the studies. We can see that the attributes of performance, scalability, and resilience are the main concern of most of the studies. So, this fact is not surprising, since those attributes are benefits sought when developing Microservice-based systems. 2 studies addressed security and reliability problems. Reusability, portability, and flexibility were the focus of only 1 study each. Finally, 4 studies didn't specify the quality attributes addressed. The research question 7 aims at identifying in which microservice architecture layer the adaptations were applied. The results showed that the vast majority of studies proposed to carry out self-adaptation in terms of the system's infrastructure, which is strictly linked to the microservice instance in execution, and regards containers and their orchestration tools. In contrast, no study has presented self-adaptation strategies only at the application level, which concerns the functionality of microservices, but 5 studies presented multi-layer self-adaptation approaches. 2 studies didn't make it clear in which application layer the self-adaptations were intended. Therefore, they are included in the not specified category. At last, 4 studies in the not applicable category are philosophical papers and do not discuss in which layer of microservices the adaptations are applied. Finally, the research question 9 shows the technologies that have been addressed by the studies. Among the 21 analyzed studies, 16 of them mentioned the specific technologies in the contributions. We classified the technologies in 15 different categories, such as container, storage, metrics, and so on. It can be seen that the majority of the studies address container technologies with 14 studies, followed by storage technologies with 9 studies. Another highlight is that technologies for monitoring, collecting, and analyzing application metrics were addressed by 8 studies. Besides, it is interesting to see that, even being a relatively recent technology of microservices, service mesh comes in fourth place, being addressed by 4 studies. Following, with 3 studies each, come the categories DevOps, Machine Learning Tool, and Cloud Infrastructure, which indicates that those concepts are gaining attention in the approaches. Finally, a group of 8 technologies that have been addressed by only 2 or 1 study appears, like logging, modeling, and so on. So, after drawing the general picture of self-adaptive Microservice-based systems, it is possible to identify gaps that open new research opportunities. The first one is related to the resilience and reliability in microservice composition. Talking specifically about resilience, the recovery of failures can be different according to the criticality level that the activity implemented by the microservice has on the composition process. In this sense, although resilience is the third most addressed quality attribute, most of the studies focus on the infrastructure layer, which indicates a lack of work that proposes self-adaptive approaches for resilient microservice composition in the application layer, and it is an interesting area of research. There are several works in the literature that address self-adaptation techniques through architectural models associated with domain-specific language (DSL). Despite showing great potential in being used in other contexts of self-adaptation, mainly in the creation of adaptation plans, this approach is almost unexplored in the context of microservices. In this sense, a promising approach consists on investigating the use of DSLs that can assist the task of specifying the possible adaptation actions using a higher abstraction level in the context of self-adaptive microservices. The next topic concerns the deployment of microservices. The deployment of new application updates in production is one of the biggest challenges faced in DevOps and microservices. However, according to our results, no study took into account the deployment of microservice updates in a progressive manner and with the least possible impact. Thus, an interesting possibility would to be exploring the automation of deployments, for example, canary deployment, which requires a high level of monitoring of what should be implemented, as an activity that involves the use of self-adaptation techniques through feedback control loops. This could open up a range of possibilities for new self-adaptive systems for microservices, from systems that provide basic self-scaling to systems that provide self-adaptive deployments. In this work, we've conducted a systematic mapping through 10 primary research questions and identified how self-adaptation approaches are being applied to microservice-based architectures. We analyzed 21 studies after the definition and execution of a rigid mapping protocol. So, the main findings of this work are: most of the studies aimed at developing solutions that deal with self-healing and addressed mainly the performance and scalability quality attributes. The focus of the most of the studies are reactive adaptation strategies through a centralized adaptation control logic and in the system infrastructure level. And most of the analyzed studies propose an architectural model that addresses self-adaptive capabilities in microservice-based applications. So, by analyzing the systematic mapping results, it was possible to propose some promising research directions that have not been properly addressed yet. And that's it. Thank you very much for your attention.